Ever feel like coding's kind of, this exclusive club? Like there's a secret handshake, some logic language you got to master to get in?
Yeah, I see that.
Well, today, on this deep dive, we're ditching the velvet rope, right? We're going to crack the code, so to speak.
I like it.
We're using Kickstart Your Programming Career, this awesome resource, by the way, to show you exactly how logic is your coding superpower.
Yeah.
And the best part, you don't even need to know coding to get this.
That's what I love about this topic. It's amazing how many people think, oh, coding, you got to be like a math whiz.
Right, like some kind of human calculator.
But honestly, it's way more about thinking like a builder, an architect, than some, equation crunching machine.
Okay, so instead of hardcore math, it's more about how you approach a problem, like that structured thinking thing.
You got it. See, it's all about breaking down this big problem into these smaller, bite-sized steps a computer can actually get.
So it's like, if you're planning a trip, right, you wouldn't just hop in the car and just drive hoping for the best. You'd, book your flights, find a place to stay, map out the fun stuff you want to do, all in some kind of order that makes sense.
Exactly. And just like that well-planned trip keeps you out of trouble, logic in coding, that's your guarantee your programs don't go haywire. They run smooth, they're efficient, and what's really cool is how this spills over into your everyday life, that problem-solving muscle. It gets stronger.
Now that you mention it, I kind of see that in how I tackle things now, not just code. It's like coding gives you this X-ray vision for everyday problems,
That's it. Say you're dealing with some crazy issue at work, right? Coding teaches you to pause, zoom in on the problem systematically, really pinpoint the root cause. Then you build your solution step by step, just like you would when you're, debugging a wonky piece of code.
So coding's like this mental boot camp. You come out with all these tools to dismantle problems, build solutions, whether it is a software bug or, like you said, just a real-life mess.
And just like leveling up in your favorite game. Right. You master this logic thing, bam, new abilities unlocked. Ever get those annoying off by one errors?
Tell me about it. It's like missing your train by a hair because you miscalculated. The worst.
Classic example of where logic saves the day. Clearly define how your code's grabbing data, moving through stuff, and boom, no more silly mistakes. Your code's cleaner, faster, more efficient. You look like a pro.
So it's kind of like, instead of this frantic bug hunt, it's more like Sherlock Holmes, right?
Yeah.
Following the logic to crack the case.
You're spot on. And speaking of leveling up, mastering this whole logic thing, it isn't just, oh, my code works, yay, me. It's about that next level, elegant code, efficient, the kind you can actually come back to and understand.
And you mentioned efficiency before. For someone who's just starting out, what makes that so important? Why should they care?
Okay, picture this. You're trying to navigate a city, right? You got two choices. A messy, scribbled-on napkin or this beautifully organized map. Which one are you going for?
The map, obviously.
Yeah.
Who even uses napkins anymore?
Exactly. Efficient code, that's your map. It's not just faster, it's understandable. For others, sure, but mainly for you when you come back to it later.
Makes total sense.
Yeah.
So you're thinking ahead, right? Preventing problems before they happen makes your code adaptable. Like it's future-proofed.
100%. And Kickstart Your Programming Career, they get this. They even dive into how to actually practice this logic stuff, like puzzles, but we're not talking Sudoku here, though I do love a good Sudoku.
Okay, good. Because as much as I love a good brain teaser, I'm more about that real-world coding application.
And they get that. The article talks about this thing called Boolean logic. Sounds kind of scary, but it's really just how computers make decisions at their core.
Oh, right. I've seen that around. Andy, OR, all that. That's what we're talking about.
That's it. It's like the secret handshake we were talking about before, but instead of getting into some club, you're talking to the computer. You're telling it what's what. Like, imagine you're building a search bar, right, for an online store. Someone wants Blue Andy cotton pants, or maybe shoes or sandals, whatever people are searching for these days. Boolean logic, that's how you translate that into actual code. The filter works.
So it's not just some abstract idea, it's the actual language we use to talk to computers, make them do their thing.
Boom, you got it. And then the article goes on about pseudocode and flowcharts, other tools to sharpen those logic skills.
Those always sounded kind of intimidating. Are they as complicated as they sound?
Not at all. Imagine writing out your code in plain English before you actually code it. That's pseudocode.
So instead of diving into the deep end with all the jargon, you're kind of like, okay, if the user clicks here, then this happens. Like you're sketching it out first.
Exactly. It's a roadmap, pure logic, no pressure to get the code perfect just yet. And flowcharts, same idea, but visual. Boxes, arrows, the whole shebang.
So you can pick your tool, right? Words or pictures, whatever works for your brain.
It's all about finding what clicks for you. And this isn't about, like, being born a logic genius, okay?
Yeah.
Kickstart your programming career makes that crystal clear. It's practice. You hone it. You get better.
Music to my ears. But then, how does all this logic stuff actually work in different types of coding? Because we've got procedural, object-oriented, functional programming, all that. Do they use logic differently, or?
Great question. Let's say you're building a house, okay? Procedural programming, that's like following the blueprint to the letter. Foundation, then walls, then roof. Nice and linear.
So it's great for beginners because it's how we naturally think, right?
Yes.
Step one, step two.
Exactly. Now, object-oriented, this is more like pre-built Lego blocks. You got your walls, windows, doors, all ready to go, each with their own thing they do. You're just putting them together in different ways.
So instead of a list of instructions, it's more like objects interacting with each other.
Nailed it. And functional programming, that's your toolbox. Hammer, screwdriver, wrench, each with a specific job, and you use them to get the job done. Whatever works best for that particular task.
So different ways of applying logic, all depending on what you're building, how complex it is, all that.
And knowing this, right, understanding those differences, that's what makes you a better coder. Way more adaptable. But no matter how good you get, there are these classic logic traps, things that trip up even the pros sometimes.
It's good to be reminded that we're all learning here. So what are some of these pitfalls we got to watch out for? Spill the tea.
Well, those off by one errors, the ones that drive everyone crazy?
Oh, yeah, those little buggers.
They're like the common cold of coding. Everyone gets them.
Yeah.
But good news is they're preventable with a little bit of, looking ahead.
So it's all about double checking, right? Especially when you're dealing with those sequences, indexes, all that. What else should we watch out for?
The dreaded infinite loop. Classic blunder. It's like you set your alarm to snooze every 5 seconds, but forever.
Okay, that sounds terrifying. And probably not great for my sleep schedule, let alone my code.
Exactly. Your program's going to be stuck in this endless loop going nowhere fast.
So how do we avoid that? Like, what's the coding equivalent of hitting the stop snooze button?
You got to have an exit strategy, right? Like a condition that tells your code, all right, we're done here. Time to move on.
So planning is key, right?
Mm-hmm.
Clear conditions, no coding all-nighters for us.
Smart. And then there's this thing called, get this, logical short-circuiting. Sounds like something out of a sci-fi movie.
Right. Okay, I'm intrigued, but also a little scared. What is that exactly?
Basically, it's about the order of things. Like, say you're checking if someone's allowed to do something in your app, right? Maybe they need to be logged in, A and D have a certain user role. But if your code checks the login first and it's a no-go, it might just skip the whole user role part.
Oh, I see. So it's like, you're not logged in, case closed, don't even bother with the rest.
And that, my friend, can lead to security issues. Not ideal. So yeah, order matters. A lot.
It's like those choose your own adventure books, but with way higher stakes.
Exactly. Every line of code, it's a decision, a path. Choose wisely, my friend.
So to wrap things up, kickstart your programming career. They don't just point out the potholes in the road, right? They leave us with this awesome question. What problem do you want to solve with code?
I love that. It's so inspiring, right? Because coding, it's not about the jargon or the rules. It's about having an idea, a problem you want to fix, and actually making it happen.
And now, after this deep dive, we can approach those problems with a fresh perspective, right? We've got the logic toolkit.
Exactly. We're not just randomly typing, hoping for the best. We're breaking things down, thinking ahead, building smarter, more efficient solutions.
So who knows what amazing things we can create, right? Big thanks to Kickstart Your Programming Career for the insights, and to you, our awesome listeners, for joining us on this coding adventure. Until next time, happy coding, everyone.